going around. Okay, today we will see continuation for the well. It's an important Konnurs question. So under this one we have two questions guarantee anyone is asking as a Konnurs in the board as well as important for competitive examination also. What is that one? Integrated rate equation for zero order as well as first order. So first of all, what is the integrated rate equation? What are the usefulness? We will see first of all. First of all, I am taking one of the chemical reactants or converting into products. Okay, first of all, we will write the rate of reaction in terms of differentiation. Means, how can we write? Minus of change in concentration of reactant by time change or nothing but change in concentration of the product by time change. We can express the rate of the reaction like this, but in this equation we are getting at a time relation between the rate of the reaction, concentration and time. Okay, but we know one more concept, it is nothing but rate law. Okay, according to rate law, what we can write? R is equals to K into concentration of the reactant power N. We don't know what will come in its powers. It is depending upon whether it is elementary reaction or complex reaction. Okay, in this equation, rate is nothing but a relation we are getting in terms of concentration and rate constant. But by using these methods, if you can calculate the speed of the reaction, you may not get accurate values. Some errors is coming. To avoid, why? Because here they are related with which ones are concentrations. Okay, while calculating concentration, you may get some errors. That's why rate of the reaction is also not 100% accurate. Some error values is coming. To avoid this problem, what has to be done? We have to do. We can or we should. We will integrate the. We will integration of. We will do the integration of differential equation. Differential equation. What is the concept? By using these two, we can get the rate of the reaction, but there we are getting some errors. To avoid the errors, we are doing integration. Those differential equation is called as integrated rate equation. First of all, I am explaining first Konnurs question. What is the integrated rate equation for zero order reaction? Concept understand very carefully, a very important concept. Okay, first of all, I am taking one of the chemical reactants are converting into products. Okay, write down rate law. According to rate law or rate equation, what can be written? R is equals to some constant into what is coming zero order. No, zero order means what? Concentration of the reactant power is coming 0. Alright, that we can do one more thing. R is equals to K into instead of reactant power 0 can be written as 1. Is there any problem? No. Why? Because anything power 0 is equals to 1. So anyway, you got R is equals to rate constant you got. But you see carefully what I am writing. We got right now R is equals to K. But rate of reaction in terms of differentiation, what can be written? Rate of reaction in terms of differentiation minus of change in concentration of reactant by time change is equals to K. Are you clear? Yes. Now do simplification. dr term, leave it left side, dr. Then what we are getting both sides multiply with the negative sign. Then we are getting a minus k into dt. We are getting. Okay, right now equation and differentiation, but I want to do integrated equation. That's why I do both sides. Both sides integration. Both sides we have to do integration. Okay, then what happening? Integration of change in concentration of reactant, integration of minus k into dt. Okay, just I will tell some important maths. In maths you will get integration, and just what is important here I will explain when you see. Okay, integration of change in concentration of reactant here. What is the constant here? Minus k is constant, bring outside, and integration of dt. Okay, in mathematics, you know very important formula, integration of dx is equals to, yes, only x. Integration means is inverse of the differentiation. So integration differentiation cancel remains x. Okay, like this one more formula is there. That if you know those integration formulas, you can enjoy this concept. Integration of dx is equals to x. Integration is the inverse of the differentiation, so both are cancelled, remains x. Okay, now here instead of x, what will be there now? Concentration of the reactant will be there. So what is coming? It's like the integration of d of concentration of R. So what will be coming? Concentration of R will be coming. Is equals to, okay, what is coming here? Minus k as is. Integration of dt. Instead of x, what will be there? T is there. So what is coming there? Kt plus I will be coming on. So I is nothing but integration constant. I is nothing but integration constant. Okay, now my concept, I want to find out the I value. For this, what I am taking, if time t is equals to 0. What is the meaning of time t is equals to 0? At the initial stage of the reaction. Then what we are getting? Concentration of the reactants is becoming the initial concentration of the reactant denoted by R0. You got it? In any chemical reaction, time is 0. Time is 0 means at the initial stage of the reaction, concentration of the reactant is denoted by R0. R0 means is nothing but initial concentration of the reactant. Substitute this information in this equation. Instead of R, what can be written? R0. Yes or no? Is equals to minus k into time is equals to 0. Minus k into 0. Anything into 0. 0 plus what is coming? I. So what you got? That implies I is equals to, what you got? R0 you got. Again substitute this R0 value in this equation, you got equation. What is that one? R is equals to minus kt plus, instead of I, what can be written? R0. This is only we are calling as integrated rate equation for zero order reaction. This is calling as integrated rate equation for which order? Zero order reaction. Zero order reaction. That's it. All of you understood? Yes. Here you got which value? I value you got. Again I value you substituted here, means integration constant you got. Then you are getting finally R is equals to minus kt plus R0. Here once again I am writing concentration of the reactant R is equals to minus kt plus R0. What is the terms is here important amount. So concentration R0 means what? R0 means what? Concentration of reactant at initial. Are you clear? R0. But what is the meaning of T? Time interval. Time. What is the meaning of R? Is also nothing but concentration of the reactant at where? At a time T. At a time T. So R0 is the initial concentration of the reactant, time T means time, and R means water. Concentration of the reactant only built after time T. So there is nothing but integrated rate equation for this equation. Once again, I am explaining some important information, you see carefully. Concentration of the reactant is equals to minus kt plus R0. In this equation, what are the variable times? Times. If time is changing, yes, after starting the reaction after 1 minute, 2 minutes, 3 minutes, yes, if time is changing, what time is changing in this equation? Anybody? Yes, what is the meaning of R1? Concentration of the reactant at time t is there. As you have a reaction, reactant is converting to the product. Initially 10 molar is there. After 1 minute, it is becoming like 8 molar. So after 5 minutes, it is becoming like 5 molar. What happening here? As the time is changing, corresponding concentration of reactant will be also changing. That's why if this time is changing, concentration of the reactant is also changing. So then automatically it is similar with one of the straight line equation. Anyway, one of the straight line equation, right? Y is equals to mx plus c. Y is equals to mx plus c. Yes, here variable terms is what? X and Y. Here variable terms is time and concentration of the reactant at that corresponding time. So can we plot the graph here? Yes, you see carefully. On x-axis, what should be taken on? Time. If you take in time here, nothing but t. And on y-axis, what should be taken? Concentration of the reactant has to be taken on y-axis. What is happening here? So we are getting a straight line with which slope? Negative slope. If you can extend this straight line, so it is intersecting here. This intersecting point is nothing but what? At a time t is equals to 0, the concentration of the reactant only denoted by R naught. That is only nothing but C is equals to R naught. C means intercept. Intercept is nothing but R naught. R naught is what? At a time t0, concentration of the reactant is falling as R naught. Okay. If you can take like this, what happening? Slope of this right line will be there. What is the slope of this right line? M. M is equals to how much? Minus k. So slope is equals to coming minus k, but reaction constant value should not be negative. That's why we are taking k is equals to minus of slope is nothing but rate constant value is equals to negative slope. He is asking a bit as it is in the competitive examination. Under zero order reaction, if you plot a graph between time versus concentration of the reactant, we are getting straight line with which slope? Negative slope. So m is nothing but minus k. Are you getting that? Yes, here one important point is there. This zero order reaction will end after some time. What is the meaning of this one? After few minutes or after particular time, what happening? The whole reaction will be closed. Whole reaction will be stopped. Why? You see here, yes, going on time. For example, after 15 minutes, what happening here? This line will be comes down or no? Yes, at this particular time, what happening? Concentration of reactant is equals to 0. There is no reactant. There is no reaction. It's also very important way. Among the options, which reaction will be stopped after some time? It is nothing but zero order. Why? Because as the reaction will be going on, at a particular time, concentration of the reactant is becoming 0. There is no reactant, there is no reaction. That's why zero order reaction ends after some time. Okay. For integrated equation for zero order, concentration of reactant at a particular time is equals to minus Kd plus which one? Concentration of the reactant at initial denoted of remove the terms. Okay, just I want to simplify this term. You see carefully. What I am doing? Kd bringing to left side, R goes to right side. So what is coming here? Kd is equals to R naught minus R will be coming. Yes or no? Then we are getting time t is equals to R naught minus R by we are getting k. Or we can write k here, time here, it is not a matter. But generally everyone is remembering this one. Means time t is equals to initial concentration minus final concentration at a time t by rate constant. Oh, sorry, I will take here k here means no problem. You can take k is equals to initial concentration of the reactant minus final concentration of the reactant by time will be coming. Okay, here I am telling one more important concept under same question only, of lifetime. Of lifetime. Already you have some idea in case of radioactive chemicals. Of lifetime is denoted by T of. Do you have any idea? Just you see. We have one of the chemical reactants are converting into products. Initially means what? Time t is equals to 0. Yes or no? Initially, we have, for example, 10 molar of reactants. Is there any chance to identify the products? No. 0. Why? Because reaction not yet started. Okay, I started the reaction. Okay, at a time t is equals to 5 minutes. At a time t 5 minutes, what I observed, concentration of the reactant is exactly 5. Automatically products will be also 5. So what is the time duration here? 5 minutes. Initially time t is equals to 0, but we are calculating information at 5 minutes. So the time gap of 5 minutes. So did you observe one thing here? Initially reactants is 10 molar. Within 5 minutes, what happening? Concentration of reactants is becoming exactly half of the initial value. 10 minutes of value means 5. So this time duration only we are calling as half-life time. Can you tell the definition? Okay, half-life time is defined as the time taken. Tell me the time taken by the reaction. Time taken by the reaction to reduce the concentration of reactant. To reduce the concentration of reactants to half of its initial value. Did you got my point or no? The time taken by the reaction to reduce the concentration of the reactant to half of its original value or initial value. Initially 10 is there. If you want to becoming 5 molar, time taken is calling as half-life time. Okay, for example, taken 5 molar you taken. Which time is calling as a half-life time? 5 has to be coming 2.5. For this change, how much time is required? I told you we are calling as half-life time. Now, we are discussing this concept under 0 order. You see, what is there here? Time t is equals to initial concentration minus final concentration by rate constant. Okay, you have to observe very carefully. If time is equals to half-life time, what happens? Okay, initial concentration is how much? R0. Okay, if time gap is half-life time, what happens? The concentration of the reactant at time t is becoming half of the initial value, no? So automatically concentration of the reactant at time is becoming like initial value by 2. At a time t, concentration is R0. If time is half-life time, what happens? Yes, sir. At that time, the concentration is becoming half of the initial value. Can you substitute in the previous equation? Instead of t, what can be written? Yes, very good. Half-life time is equals to R0 as it is. But instead of R, what can be written? R0 by 2 can be written by K will. Yes, if you can see one more step, half-life time is equals to, we are getting, take LCM and do simplification, we are getting R0 by 2K. So what is the half-life time for 0 order reaction? Half-life time for 0 order reaction. Half-life time for 0 order reaction. Half-life time is equals to R0 by 2K. From this can we tell one important thing? Under 0 order reaction, half-life time is directly proportional to R0. Yes or no? Because yes, directly proportional. That's why in the 0 order reaction, half-life time is directly proportional to initial concentration of the reactant. So I will tell you one important thing. You see, for example, he taken 10 molar concentration. Half-life time is 10 minutes. He taken 20 molar concentration. Half-life time is 20 minutes. Is it which order reaction? Is it which order reaction? 0 order. Why? Because initial concentration is increasing. Half-life time is also increasing. So that is the meaning of half-life time is directly proportional to initial concentration of the reactant. Yes, the question is like this only. Is the initial concentration of the reactant is increasing, half-life time is also increasing. Immediately we can tell it is a which order reaction? 0 order reaction. All of you getting it? Yes, you have to remember this formula. Half-life time is equals to R0 by 2K. Just I am telling some other complicated information. Actually, question is if you write up to here is enough. If you ask half-life time, you should add this concept also. But what I am explaining now is all only for competitive point of view. Take first of all reaction is what time t is equals to R0 minus R by K is there. Okay, for example, in a chemical reaction, initially concentration R0 is equals to A amount. Okay, after some time, in a particular time interval, some x is missing. In a particular time interval, x is missing is what the final concentration? R is equals to what is coming? A minus x. Are you getting it or not? In a chemical reaction, sir, I am not understanding this. You see this one. R is used like to product. Initially, concentration of reactant is R naught. Initially, is there any product? No. Okay, you are maintaining a particular time interval. At the particular time interval, concentration in this time gap, what happening? Some x is missing. This one is taking as A. At a time t, concentration of reactant is denoted by R. This comes how much? A minus x. Okay, how much is missing? That much only will be forming here. Initially concentration is A. After some time some x is missing. That remaining concentration is A minus x. Substitute in the previous equation. T is equals to R naught value is how much? A minus O. R value will be how much? A minus x. By what is coming? K is coming. That implies simplify. A cancel. We are getting T is equals to x by K. That implies KT is equals to x. K is constant. T and x relation is what? T is directly proportional to x. Is very important bit. What is the meaning of T is directly proportional to x? In case of zero order reaction, time taken by the reaction is directly proportional to what is the meaning of x? Change in concentration. Change in concentration. Very important thing. In case of zero order reaction, time taken by the reaction is directly proportional to change in concentration. To understand, I will give you one question. You have to observe very carefully. Reactants are converting into products. Initially, we have, for example, 10 molar of reactant. Products will be 0. Okay, in for example, 5 minutes duration. In 5 minute duration, it is becoming like 5 molar. Automatically, how much products will be forming? 5 molar. What is the question? In a chemical reaction, initially we have concentration of the reactant is 10. Within 5 minutes, it is changed into 5 molar. But what is the concentration after 7.5 minutes? Nice question. After 7.5 minutes, what is the concentration of the reactant? Did you got my point? Yes, you see carefully. What we told here, under zero order reaction, time taken by the reaction is directly proportional to change in concentration. Within 5 minutes, how much change is coming? 5. Yes or no? Yes, 5 molar change is coming. Okay, but here we want how much? Already 5 minute change is there. We want 2.5 minutes. For 5 minutes, 5 molar change is 2.5 minutes. How much change will come? 2.5 will come. For 2.5 minutes, change will come 2.5. Why? Because directly proportional. Okay, again what happened in this duration? How much will be decreasing? 5 minus 2.5. It is nothing but 2.5. What is the answer? After 7.5 minutes, we have 2.5 molar of reactant. Did you got that point? Yes. It's a very important, very simple logical questions. All of you get it? Which order reactions will be end after some time? Zero order reaction. What is the integrated rate equation for the zero order reaction? T is equals to R naught minus R by K. R naught means what? Initial concentration of the reactant. R is what? Concentration of the reactant at a time t. And K means what? A rate constant. Or a specific reaction rate, or calling as velocity constant. What is the off-life time for this one? Off-life time is nothing but R naught by 2K. R naught means initial concentration. So you can tell for zero reaction, off-life time is directly proportional to concentration of the reactant at initial case. From the diagram one bit here. Initial concentration, R naught values is going on increasing. Time taken, off-life time will be also going on increasing. This relation will be worked out in 0. Yes, you got my point on? Yes. Yes. See, for this class, I'm giving some competitive bits. We have a chemical reaction. In this chemical reaction, initially we have 0.01 molar of reactant. We only mentioned it is the zero order reaction. Otherwise, we can't solve. Okay. In the zero order reaction, we know already x is directly proportional to time taken. X means what? Change in concentration is directly proportional to time change. Okay, initially we have 0.01 molar. Within 10 minutes is becoming like 0.005. Means what? For 10 minutes, how much change is coming out? 0.005 molar change is coming. Yes, sir. Okay, but what is asking? After 15 minutes, what is the concentration of the reactant? For 10 minutes, this much change, but still we want how much gap? 5 minutes. Yes, do that one only. For 5 minutes, how much change has to become? Again by 2. By 2 means is nothing but 0.0025 molar. Do that one minus, then what we are getting? 0.0025 is coming. Are you ready now? Yes, just that I will give you one more question. You see carefully. For example, you have a chemical reaction. Reactants are converting into products. He only mentioned it is the zero order reaction. In case of zero order reaction, if initial concentration of reactant is 5 molar, then half lifetime is coming at 2 minutes. If initial concentration you taken as 15 molar, then half lifetime is option A greater than 2 minutes, option B less than 2 minutes, or option C is equals to 2 minutes, or option D can't expect. Can't expect means we can't tell. Yes, you will mention very carefully how to see zero order reaction mentioned.